Starship HLS will not be ready to support the Artemis 3 mission scheduled for 2027, a stark warning recently issued by NASA's Aerospace Safety Advisory Panel in a rare public meeting. This accusation directly challenges SpaceX's timeline and capabilities, striking at the heart of the company's reputation. Unlike previous criticisms that SpaceX might have dismissed lightly, this time the pushback came sharply from the top leaders of the company, including President Gwynne Shotwell, who promptly delivered a fiery rebuttal, forcing NASA to reconsider its stance. What sparked such bold claims from NASA? And how did SpaceX's leadership respond? Let's dive deeper into the unfolding situation. Last month, following an inspection visit to SpaceX's Starbase facility, NASA's advisory panel convened to assess the progress of lunar exploration efforts, including the Human Landing System, HLS, Starship variant. The panel expressed serious concerns about the readiness of Starship HLS to meet the 2027 Artemis 3 lunar landing timeline. Paul Hill, a former NASA flight director with decades of experience in human spaceflight, shared his assessment that the HLS development is facing significant delays. Since the contract award in April 2021, SpaceX has yet to deliver a complete vehicle capable of supporting manned lunar operations. To date, only design concepts and early functional tests have been presented, insufficient to instill confidence in the program's readiness for such a critical mission. Yet, when this timeline is put in context, the criticism appears less clear-cut. The Space Launch System SLS, NASA's flagship heavy-lift rocket, took over a decade from its development start in 2011 until its successful Artemis I flight. Yet NASA hails that as a major achievement despite the lengthy timeline. SpaceX, on the other hand, has had only 4 years since winning the HLS contract, which is a much shorter development window. Moreover, the funding scenario is strikingly different. NASA has invested upwards of $35 billion in SLS and its launch infrastructure, whereas SpaceX has received about $4 billion to cover 2 HLS contracts. Expecting SpaceX to work at twice the pace of SLS with less than 1/10 the funding seems like an unfair comparison, possibly setting them up for blame should delays occur. Hill went further, suggesting that achieving the rapid production and flight cadence SpaceX aims for, delivering a fully reusable, low-cost rocket with high launch frequency, is nearly unattainable. He implied that Elon Musk's ambitions might be chasing pipe dreams. Meanwhile, other panel members like Bill Bray noted that while Artemis 2 preparation remains on track, the pathway beyond, particularly Artemis 3, is fraught with uncertainty. They highlighted delays in critical technology demonstrations, such as cryogenic propellant transfer in orbit, essential for refueling Starship before lunar descent. Elon Musk met these critiques head-on, albeit indirectly. Responding to a critical New York Times article on SpaceX's HLS progress, Musk dismissed the criticism as not worthy of serious attention. When suggestions arose that NASA might shift to competitors like Blue Origin for Artemis 3, Musk's curt response was laden with sarcasm, rejecting such narratives as baseless and biased. Despite media claims about Musk's political clashes possibly risking SpaceX contracts, recent public interactions between Musk and President Trump suggest otherwise, effectively debunking the funding cut rumors circulating in the press. SpaceX's actual progress, while not fully disclosed, is moving steadily behind the scenes. Leaks reveal ongoing assembly of hardware, testing of airlocks and crew seats, and construction of a full-scale test tower for the landing system at SpaceX's test site. Given only 4 years of focused development, this rate is competitive, especially when considering the program's complexity. Historically, SpaceX has shown the ability to accelerate quickly once critical milestones are hit. For example, Falcon 1 took 4 launches to perfect the design, but then rapidly moved forward with consecutive successful flights, eventually retiring to pave the way for Falcon 9's rise as a reliable workhorse. Supporting this optimism, Gwynne Shotwell, SpaceX's president, praised the recent Flight 10 test of Starship, acknowledging it as crucial progress after earlier test flight anomalies. She highlighted the upcoming Flight 11 will introduce an upgraded Starship V2, with sights set on the more powerful Starship VR-3, expected to debut soon. VR-3 is envisioned as the vehicle capable of taking humans to the Moon and Mars. Shotwell pointed out the critical milestone ahead is validating orbital refueling, a challenging technology involving docking and transferring cryogenic propellant at orbital speeds with precision. While docking itself is deemed manageable given SpaceX's experience with Dragon capsules, the actual transfer of supercold fuel poses significant engineering hurdles. Despite the technical challenges, Musk and Shotwell conveyed a resilience and confidence rooted in experience, emphasizing that early failures are part of the innovation process. Musk has stated that unless major setbacks arise, SpaceX plans to demonstrate full Starship reusability next year, enabling delivery of over 100 tons to orbit. This vision extends beyond Artemis 3 to maintaining U.S. leadership in lunar exploration amid rising competition from China. China's space program is rapidly advancing, quietly testing powerful two-stage combustion engines and developing reusable boosters. Their private company Landspace recently tested a liquid methane engine reaching half its target thrust, signaling capabilities approaching SpaceX's Raptor 2 engine performance. These developments underscore the tight timeline race in lunar exploration technology. Meanwhile, SpaceX is enhancing its logistical infrastructure to support rapid Starship launches. Elon Musk recently disclosed the name of a new cargo vessel, Watership, to transport spaceship from Starbase to Cape Canaveral, designed to ferry large Starship components between Texas and Florida. This new ship follows Musk's pattern of naming vessels after references from the sci-fi culture series by Ian M. Banks, continuing a tradition with previous ships also serving the Falcon 9 program. This ship's design allows it to carry Starship's main components horizontally, a necessity because of size and road clearance restrictions between production facility Starbase in Texas and the launch facilities at Cape Canaveral's LC-39A, where SpaceX is building a new gigafactory and launch pad for Starship. While the launch pad is nearing readiness, the gigafactory construction remains underway, with full operations expected around 2027. Until then, transporting Starships by sea is essential. In summary, while NASA's caution reflects valid technical hurdles and risks, with the Artemis 3 Starship HLS timeline, SpaceX's response showcases determination, strategic planning, and historical agility in spaceflight development. The company is not only preparing to meet these challenges, but also pushing the boundaries of what's possible in reusable rocket technology, orbital refueling, and lunar landing systems. The upcoming years will be critical in proving whether SpaceX can fulfill its ambitious vision and reshape humanity's presence on the Moon and beyond.